It's like a blast off. It's pretty cool. Last week, we started our rational expressions. Rational expressions just means the fraction unit. We had 3 steps to every question that we talked about. The first step every single time is factor. Right? And some questions you can't factor. So if we look at this first multiplying of rational expressions question, there is no factoring that can be done. There's no factoring because there's no addition or subtraction. So that's like the giveaway that there's no factoring that's available. The second step to any question is that we need to state our non-permissible values, which we call NPVs. Just a reminder of what NPVs are. They're things that do what? Yeah, they're values that cause us to divide by 0. But you're not allowed to divide by 0 in math. So a non-permissible value is something that would cause you to divide by 0. If you look at this question, the 2 areas that I would need to check for dividing by 0 would be right here and right here. Because those are 2 different spots where I'm doing division. The blue one that I'm highlighted is divide by 10. There's no letter there. So there's no way I could make 10 equal 0. The red one that I've highlighted is 2 times c. There is a possibility that I could make that equal 0. What value of c would make that 0? Close. That's one that people fall for. Because usually it's like 2 plus c, right? And then people are like, oh, it's the opposite number. But when they're side by side like that, and there's nothing in between them, the way you would make it 0 is if it was 2 times 0. So what value of c can't you have? You can't have 0. Right? So anytime there's a monomial letter, that letter cannot equal 0. Awesome. The third step that we did in every single question was we simplified. Simplifying when it's multiplication of rational expressions. What we like to do is combine it into one rational expression, so one fraction, and then simplify anything that can simplify. The way we combine them into one is we multiply across the top and we multiply across the bottom, and that becomes one fraction overall. On the top, c squared times 5d, we say numbers go with numbers and letters go with letters when it comes to monomials. 5, there's no other number on the top to multiply by. C squared, there's no other c's to multiply by. And d, there's no other d's to multiply by. So the top just becomes 5c squared d. Divided by. On the bottom, we have 10 times 2c. They're both monomials, so numbers with numbers, letters with letters. 10 times 2 is 20. C has nothing to multiply by, so it's just c. So when we're simplifying, first step is combine the top to become 1, bottom to become 1. Now we have one fraction. With one fraction, we can then reduce that fraction. We reduce this fraction by looking at the numbers first. So we have 5 over 20. If you're not sure what 5 and 20 reduces to, you can put in your calculator, right? So you go 5 divided by 20, math, frac. It'll tell you that you have a 1 on the top and a 4 on the bottom. The way they got that was they divided both the top and the bottom by 5. The next thing you would look at is your c values. So we have a c squared on the top, a c on the bottom. The top has more, so the top will end up with a c. There was 2 on the top, 1 on the bottom, so 1 canceled out from top and bottom, leaving me with 1 on the top. And for d values, there is no d on the bottom, so it would just be 1d on the top. Your answer would be 1cd divided by 4. Realistically, we wouldn't write the 1, so we would probably go cd divided by 4. It's unlikely you see it, but they might even write this answer like this. 1 over 4 C, D. So remember when you have a fraction with a number on the bottom and it's just a number, you could actually pull it out like a coefficient. I don't think you'll see that, but you might. It's most likely you see this answer, CD divided by 4. Awesome. Second question. Second question is a little more typical of what we would see because it's not just monomials. Right? That first question was all monomials, which kind of has its own rules almost, right? Monomials go together easily, monomials cancel out easily. But if you look at the second question, we now have binomials mixed in throughout the question. All right. Even though it's a harder looking question, we follow the same 3 steps. Step 1 is factor. Looking at that question, there's nothing I can factor. The way I know there's nothing that can factor, I can only factor binomials. So these 3 red things are the things I'm going to try to factor. If I look at all 3 of those things, none of them are difference of squares, meaning I can't square root them. And none of them have something that could divide out of them. So for instance, like if I look at this one up here, the first one I just circled, there's no number that could divide out of both terms, and there's no letter that could divide out of both terms. So there's no greatest common factor that I could remove. Second step, NPVs. NPVs are things that cause you to divide by 0. Remember, if you have to explain that on a test, that's the wording you're looking for, right? If my NPV was 0, I would say 0 causes me to divide by 0. That's why it's an NPV. That's how you would explain your answer. All right, looking at this question, the 2 places I divide are here. There's one division, and here. There's a second division. Looking at the first one, I have 3 times x minus 1. We're going to look at 3 first because that's the monomial. Just 3. Is there any way that 3 would change into be 0? No, because there's no letter attached to it. So 3 is going to be kind of fine on its own. The next thing I'm going to look at is x minus 1. I'm going to ask myself, what value would make that equal 0? So if x equaled what, that would become 0. If it equals 1. That means one of my NPVs is x cannot equal 1. It would cause me to divide by 0. The last spot I'm going to look here is this 2x. It's a monomial, and there is a letter in the monomial. So I could make that monomial 0 if x equaled 0. You got it. So those are the NPVs. Remember, on your diploma exam, you cannot miss any and you cannot have any extra. So don't just like guess and throw them in there.
So if there was one on the second top, like
like if there was another one right here.
No, on the other side.
Right here.
Yeah.
So say that had been something else.
Yeah.
In this instance, we don't check. You're thinking of division, which we're going to do in a second. We don't check because this symbol right here is multiplication. If that was division, that's when we check the top. Yeah. Okay. We factored. We simplified. We factored. We NPV'd. Now we need to simplify. When we go to simplify, what we like to do is combine it into one fraction first and then try to reduce it. So to combine it into one fraction first, I want to multiply everything across the top. When you're multiplying, monomials go together and then you do not expand anything else. So when I'm multiplying this together, I will do 4x times 5 to become 20x. But I do not expand my binomials. So I would leave x plus 3 as x plus 3, and I would leave x minus 1 as x minus 1. I only multiply the monomials together. My reasoning for doing that is because when I go to reduce, remember that you can only reduce entire packages or entire binomials. So I want it like that so that I can cancel things out easier. On the bottom, I'm going to do the same thing. Monomials go together, so I have a 3 as a monomial and a 2x as a monomial. That would become 6x. And then I leave the x minus 1. I do not expand that stuff out. I've successfully written it as one fraction. I can now work to reduce that fraction. We will start with the monomials. So I have 20 and I have 6. Both of those numbers could divide by 2 to become 10 over 3. If you didn't know how to do that, your calculator does it for you. 20 divided by 6, math frac. It'll tell you what number goes on the top, what number goes on the bottom. The next part of my monomials, I have an x and an x. Those x's can cancel because they were both monomial x's. On the top, my next thing I have is x plus 3. X plus 3 is a binomial. It can only cancel with other binomials, so other packages. There is no x plus 3 on the bottom, so that means that x plus 3 will remain on the top. It cannot cancel out. My final thing that I have is I have an x minus 1 on the top, x minus 1 on the bottom. Those are exactly the same packages, so they can cancel out, making my final answer 10 times x plus 3 divided by 3. How do we feel about that? Feel like we remember it? Awesome. Division. So when you're dividing a fraction by a fraction, we still follow the same 3 steps. The first step is factor. In A, we can't factor it. Right? There's nothing that factors out. Second step is NPV, things that cause you to divide by 0. I want to look at any spot that there's a division symbol. So there's a division symbol here, division symbol here, and then there's this division symbol in the middle. That division symbol means that you're dividing the first fraction by this value, this numerator. So if that numerator was 0, you would then be dividing by 0, which is not allowed. So it's a third spot you have to check for NPVs. Looking at that green highlighted spot that I have, what value would make that green area equal 0? 0. It's a monomial with a letter. Monomials with letters, that letter can't be 0. Fantastic. That was step 2, NPV. Step 3 is simplify. When you have a fraction divided by a fraction, it's really hard. So we have a way of making it easier. What we do with fractions and fractions is we kiss and flip. Kiss means you take the division symbol and you change it to a multiplication. Flip means you take the second fraction and you flip it upside down. Whoa. The first fraction remains the same. Then you have a multiplication question. And now you're just doing the same steps we did on the last questions. Go across the top, go across the bottom, try to combine it to become one fraction, then reduce that one fraction. So if I'm looking at the top, I have 5n to the power of 4 times 6. The 5 and the 6 combine to be 30. And then n to the power of 4. On the bottom, I can't combine those yet because there's a squared, right? It is a monomial, but it's a monomial squared. So I actually have to put that squared into the brackets to become 25n squared. And then I can multiply across the bottom. So the bottom would become negative 50 n squared. I only expanded that that exponent because it was a monomial. If it had been a binomial, I would have just left it alone. Now looking at this, numbers with numbers. Okay, so 30 and negative 50 can both divide by 10. We also do something called floating that negative to the top, right? It's just more standard to write the negative on the top instead of the bottom of a monomial. So I would write this as negative 3 over 5. I then look at my letters. I have n to the 4 and n squared. The top one has more, so I know the top one should get the n in the end. 4 versus 2. 2 of them would cancel on the top and the bottom, leaving me with 2 left over on the top. Remember our exponent rules that we subtract exponents, so if you're still using that method, that's fine. So you go 4 minus 2 is 2. Awesome. Second example. First thing, factor, already been factored for you. Second step, NPVs. NPVs are places that cause me to divide by 0. So I'm going to have to check this 3x, this x minus 2, this 4, and this x plus 1. And I'm going to check all the things that would make those equal 0. Starting with the 3x. What would make 3x equal 0? If x equaled 0. If I look at my next monomial, I have an x. Again, x would not be allowed to be 0 because it's another monomial with a letter. We don't need to write that twice. I don't need to say x can't be 0, oh, and x can't be 0, right? That's redundant. So just leave it as writing it once, and then you're good. The next space I check would be x minus 2. That means x cannot equal 2. Because this is a division, I need to check the second fraction's numerator, the top. There's nothing that will make 4 equal 0, but there is something that will make x plus 1 equal 0. It would be negative 1. Again, that would be a wonderful opportunity for the diploma examination to say, what are the NPVs? And then it would be explain why negative 1 would be a non-permissible value. And your explanation would be negative 1 would cause me to divide by 0, which is not allowed. Awesome. I don't think you have to go into detail about why you can't divide by 0. Pretty sure just stating that would be okay. Second step. Oh, we did second step, NPV. Third step, simplify. Because it's a division of fractions, we kiss and flip. Kiss means you turn the division into multiplication. I'm going to actually represent multiplication with a dot instead of an x, just because then the x's look the same. And you flip the second fraction. So it's now x times x minus 2 divided by 4, x plus 1. The first one is still 2, x plus 1 divided by 3x. Again, we try to write it as one fraction, then reduce. To write it as one fraction, the top one would become 2x, x plus 1, x minus 2. The monomials combine to become 2x. The binomials all stayed the same. In the denominator, the monomials combine to become 12x, and the x plus 1 would remain x plus 1. Once you've written as one fraction, you try to reduce that fraction. To reduce that fraction, you look at monomials. So we have 2 and 12 would become 1 over 6. and the x's would cancel. We then look at binomials. We have an x plus 1 and an x plus 1. Those would cancel. And then we look at the x minus 2, which has nothing to cancel with, so we leave it as x minus 2. Again, it's pretty unlikely your answer would have that 1 in the numerator. It's a little full paw to write it up there. So instead, we would just say x minus 2 over 6. We talked about this last day. I think one of the hardest parts of this unit is knowing when you're done, right? Because people always want to keep reducing. And as the rules get more and more complex, as we add, subtract, and solve, it can be hard to know when are you done a question. You are done a question when you cannot factor and you cannot cancel anything out. So looking at that, I can't factor it. People would probably be okay with that. But can you cancel more out is where people would make a mistake here. What they typically would do is they would see this 2 and this 6. And the urge is to cancel those out to become 1 over 3. Because they both divide by 2. The reason you can't do that is because the 2 on the top is not a monomial. And the 6 on the bottom is a monomial. The 2 on the top is part of a binomial, which is x minus 2. So what you'll see me do in this unit a lot is I always leave my brackets. Even in my final answer, I leave my brackets so that I don't forget, oh yeah, that 2 is part of the binomial. Binomials can only cancel with other binomials. This is my final answer. I can't simplify anymore. Especially when it comes to letters, that's when people make mistakes. Had there been another x on the bottom, people really, really want to cancel those x's out. Right? And you're over-canceling things. Simplifying is hard because you don't get like a perfect ending point. Right? You know, when we solve, at least we know we have x equals a number and we're done. When it comes to simplifying like we have here, it's hard to know when you're done because you never get a final answer really. Awesome, that's multiplying and dividing. We had done both of those last day, so it should have been somewhat review. Here's 2 hard ones. I'm actually going to do them with you, and I'm also going to rewrite them. So some of these would not be on your diploma exam. Remember that you will not have to factor a trinomial when it comes to simplifying. That means you would not have to factor this. Oh, why would it let me write? You wouldn't have to factor this, this, or this. Right? Those things would all come factored for you. So I'm going to change those right now so you can put the new values in your notes. And then we'll do the question together. So instead of 2x squared plus 5x plus 4, it would be x plus 4x plus 1. And if you remember how to do that, that's fantastic. If you don't, that's okay. I can teach you ways around it when we do use it. In the denominator, there would be a GCF of 2. So a 2 would come out first. And then you would be able to diamond method that. So you'd be looking at things that multiply to be 4 and add to be negative 4. So you'd have x minus 2 and x minus 2. Fantastic. I'm going to give you a chance to do this in steps, and I will do it with you. The first step to every question is factor. There is more factoring in that question. So I want you to try to factor right now. Okay, factoring this. Looking at the first fraction, that wouldn't factor. So I would still have x plus 4, x plus 1. And on the bottom, I would still have 2, x minus 2, x minus 2. The other fraction, though, can factor. So if I look at the top here, what I could do to 4x minus 8 is I could take a greatest common factor out. I could GCF it. I could take a 4 out. leaving me with an x minus 2. In the denominator, I have an x squared minus 1. I can't GCF that, but what I can do is I can do a difference of squares. It's a difference question because it's subtraction, and I can square root x squared and I can square root 1. So this would become x minus 1, x plus 1. Again, we reviewed how to do that in the last class, so if you're still struggling with difference of squares or GCF, come talk to me. We'll figure it out. Like, you can learn how to factor in an hour of it. Not even, half hour. You just got to come ask for some help. Awesome. Step 2 to every question is state your NPVs. I'll give you a second to try to do that on your own. Okay, NPVs, things that cause me to divide by 0. Looking at this, I want to look at the denominator. Things that cause me to divide by 0. Nothing is going to make this monomial of 2 equals 0. X minus 2 would have an NPV of x cannot equal 2. 2 minus 2 would be 0. 0 is not allowed. The other one would also be 2. We don't need to write it again. Second fraction, I have an x minus 1. That means positive 1 would cause me to have a 0. The other one, x minus 1, that means negative 1 also wouldn't be allowed. I typically write it like this, positive, negative 1. If you put 1 comma negative 1, that's the same answer, and you do not need to worry about it. I just want you to see that notation because it's maybe been a while since we've done plus minuses. Step 3, simplify. Simplify means write as one fraction and then reduce that fraction. On the top, I can write that as one fraction. Monomials go with monomials. The 4 is just going to be by itself. Binomials just all get written out. So I have x plus 4, x plus 1, x minus 2. In the denominator, monomials go with monomials. So 2 is still there. Then I have x minus 2, x minus 2, x minus 1, x plus 1. At that point, you can now reduce it because you've written it as one fraction. When reducing it, monomials go together. 4 divided by 2 would leave me with a 2 on the top, a 1 on the bottom. You don't need to write that 1. X plus 4s can only cancel with other x plus 4s. There aren't any. So I put x plus 4 on the top. X plus 1 can only cancel with other x plus 1s. There is an x plus 1 on the bottom, so they cancel out. X minus 2 can only cancel with another x minus 2. On the bottom, there's 2 x minus 2s. If there's 1 on the top, it can only cancel out 1 on the bottom. So it's only going to cancel, I'll pick the middle one. Doesn't matter which one you pick. Looking at the bottom, we have dealt with the 2, right? The 2 and the 4 canceled out. And we have an x minus 1 and an x minus 2 left over. Both of those need to get written out. So x minus 2 and an x minus 1. And I am now done. The reason I'm done is I can't factor and I can't cancel out anything else. So those binomials, I can't cancel any of the binomials completely out with another binomial. I understand I have an x on the top and an x on the bottom, but they're all attached in packages, right? They're stuck with their binomial. So unless you can cancel out the entire binomial, you can't do anything else. Okay, we're going to try the second one now. The second one is a little bit more challenging to factor. I will factor the trinomial for you. So that trinomial should not have been 12x squared minus 60x plus 75. I've done it on the board up here really quick if you want to see. it should have been 3 times 2x minus 5 times 2x minus 5. That is now completely factored on that top. I'll give you a minute to now try to do the first step, so factor that entire rational expression question. Okay, if you factored that thing, we'll start with 4x minus 10. 4x minus 10, I can take a GCF of a 2 out. 4 divides by 2 and 10 divides by 2, leaving me with 2x minus 5. In the denominator, I can't factor x plus 3, but I am going to put it in brackets. The reason I put it in brackets is to remind myself it's a binomial, it's a package. I can't cancel it out with anything else. Then I have divide by. And I've already factored the top for you, so it's 3, 2x minus 5, 2x minus 5. Again, you will not have to factor a trinomial on your diploma exam if you don't want to. Okay, I'll show you in the future a spot where we might have to, and how you could avoid doing it if you wanted to avoid doing it. In the denominator, 2x squared minus 9. When you go to factor, the first thing you always check for is a greatest common factor. That thing does have a greatest common factor. I could take a 2 out, which would leave me with x squared minus 9. If you did that, that's wonderful. But after you do a greatest common factor, you have to check to see if you have another factor you could do. Looking at that x squared minus 9, I could do difference of squares on it, meaning that I would have the 2 out front, and then square rooting x squared minus 9 would be x minus 3, x plus 3. Those are the tricky ones, where you have to GCF it, then difference of squares it. Fantastic. Step 2, state the non-permissible values. This is a little trickier. 1, because it's a division question. 2, because some of the binomials are hard to tell what the answer is. I'll give you a minute to try it on your own. See if you can state those NPVs. All right, the non-permissible values. Looking at the non-permissible values on this guy, right here, I have an x plus 3 in the denominator. That means x cannot equal 3. I'm going to do it up here. I like to always put my NPVs in the same spot, so I always know where they are. I put them up beside the original question. It just keeps my work organized, especially on some of these questions that get kind of messy. If I put my NPV in the middle of the question, I might lose it later on. So I try to make it nice and clear at the top. The next thing I look at is this 2. Nothing will make that 2 equal 0 because it's just a 2. Then I look at this binomial right here. I have x minus 3. That means I'm not allowed to have positive 3 as an NPV. Sorry, I'm not allowed to have positive 3 as a value for x, which makes it an NPV. You'll notice this time I wrote them separate, negative 3, positive 3. That's fine. If you write it as plus minus 3, also cool. The next binomial is x plus 3. X plus 3, you would not be allowed to have x minus 3. We already accounted for that. On the top, the reason I'm checking the top is because of this division symbol. Right? So I need to check this 3. Nothing will make that 3 equal 0. And then I have 2x minus 5s. So they're going to have the same NPV. So I'm only going to do it once. If you can't immediately see what the NPV is of a binomial, what you want to do is take that binomial and on the side, say that binomial cannot equal 0. So you do that for the ones that it doesn't immediately stick out to you what the answer is. And then you just do like simple algebra like we would for any equality. This is just going to be a doesn't equal sign. We want to get x by itself, so we do opposite operations, starting with additions and subtractions. So I'm going to add 5 to both sides. This gives me 2x cannot equal 5. Then I want to get rid of the 2, so I divide by 2. That gives me x cannot equal 5 over 2. If you put 2.5, that's fine as well. I would leave my answer as a fraction. It's a good habit to get into because we typically deal with fractions. Okay. You've now done the first step, factor, second step, NPV. Time to move on to the third step, which is simplify. You need to write it as one fraction. We need to kiss and flip this thing. So the first fraction doesn't change. The second fraction does. It'll now be times instead of divide. And now you're going to flip the fraction. So it's 2x minus 3, x plus 3. Divided by 3, 2x minus 5, 2x minus 5. Your next step, once you've kissed and flipped, is to write as a single fraction so that you can then reduce it. To write as a single fraction, monomials go with monomials. So the 2's on the top would become 2 times 2 is 4. Then all the binomials get written out. 2x minus 5, x minus 3, x plus 3. In the denominator, monomials go first. There is nothing to multiply by that 3. Then we have x plus 3, 2x minus 5, 2x minus 5. Now that it's a single fraction, we can reduce that single fraction. Monomials go together, so we're going to do 4 divided by 3. Nothing can divide into those, so they stay as 4 and 3. On the top, we have a 2x minus 5. That will cancel out one of the other 2x minus 5s. We have an x plus 3. There is no we have an x minus 3. There is no x minus 3 on the bottom, so the x minus 3 on the top stays. We now have x plus 3. X plus 3's, there's one on the top, one on the bottom. They will cancel out. In the denominator, you'll notice we have one thing left. We have this 2x minus 5, so we still need to write it. And that is my simplified rational expression. Awesome. I don't think we're going to get through rational expressions today, so we're actually going to skip this question. Whoa. Sorry. This is the one I don't like anyway. This is the one that, like, when I try to find the pattern, I have a hard time seeing the pattern. It has to do with the colors moving and the shapes changing. The answer is marked for you, so it is C. So if you want to look back on it on your own, try your best to see if you can figure out what's changing and what's staying the same and how things are changing. It's a challenging one, in all honesty. But yeah. It has to do with, like, the colors, how the colors all change. All right. We're just going to skip down to here because we need to try to get through rational expressions as much as we can. We now are going to try to add rational expressions and subtract rational expressions, which is actually harder than multiplying and dividing. The steps aren't going to change. Okay, so when we go to factor that, you can't. But we are going to do something important. That important thing in the factoring step is putting brackets. That's going to save us a lot of simple mistakes that might happen. Second step, NPVs. Things that cause you to divide by 0. If I'm looking at this, things that cause me to divide by 0 would be n cannot equal -4 or 5. Awesome. Simplifying. Simplifying means write as one fraction, then reduce. To write as one fraction in multiplication was easy. You just went across the top, across the bottom. To write as one fraction with addition is hard. The reason it's hard is you have to get something called a common denominator. The way we get common denominators is by multiplying each fraction by what the other fraction has in the denominator that fraction doesn't have. So for instance, if I look at the first fraction has an n plus 4. I don't think that it has a plus 4. I think it has an n plus 4, right? It has that entire binomial, that entire package. That means the second fraction needs that entire package. So we need to multiply the denominator by that entire n plus 4. You don't just add 4 or multiply by 4. It's the entire binomial. And what you do to the bottom of a fraction, you always do to the top of a fraction. Then I would look at the second fraction, and I would say this one has an n minus 5. The first one doesn't have an n minus 5. So I need to multiply by n minus 5 to the top and to the bottom. If you look, you now have a common denominator. My first fraction has now become this. My second fraction has become this. I'm going to write those a little cleaner so you can see that they have a common denominator. The first one in red, instead of saying n minus 5 times 4n, I'm going to put the monomial first because that's what we're used to. So we have 4n times n minus 5. In the denominator, we have n minus 5, n plus 4. We're still adding. The second fraction is now 3n on the top times n plus 4 divided by n minus 5, n plus 4. You've now successfully gotten a lowest common denominator. It doesn't have to be lowest, just get a common denominator. The reason that's useful is I can now write this as one fraction. When I go to write it as one fraction, on the top, you want to expand. Okay, so if I'm looking at the red fraction, that means the 4n is actually going to go into the brackets to become 4n squared minus 20n. And then on the second fraction, I'm also going to expand. But because I'm writing this as one fraction now, instead of just expanding 3n, I'm expanding a plus 3n. So I make sure I attach that middle symbol to the monomial. And then I multiply it in. So if I have plus 3n times n, that becomes plus 3n squared. If I go plus 3n times 4, that becomes plus 12n. And when you're combining fractions that are being added together, you expand the top, but the bottom just combines to be 1. So you would have n minus 5 times n plus 4. You just combine them to become 1. The reason we do that, okay, and I'll do this on the side. You don't need to write this if you don't want to. If you think about fractions, and we're going to think about basic fractions, okay, like stuff that we understand. So if I have 2 tenths, 2 over 10, and I add 4 tenths, I would have total 6 tenths. I would not have 6/20ths, right? That doesn't make sense. Maybe it works better with quarters. If I have 1/4 plus 1/4, and if you realistically thought about that, 1/4 plus 1/4 equals 2 quarters, right? I have 2 quarters. I don't have 2/8. I don't have 2 of something else's. I have 2, and it's still quarters. That's exactly what we've done with this rational expression. When we combined it into 1, it's a little more ridiculous, right? We have 4n squared minus 20n n minus 5n plus fourths. Sounds crazy. If I was to add that to the 3n times n plus 4 over n minus 5n plus 4 fourths, that would combine to be one thing. The bottom doesn't change. It just combines to be 1. Awesome. We have successfully combined that fraction into one fraction. Now our job is to reduce it. Before you can reduce it, you need to collect like terms with adding and subtracting. There is a lot of like terms on the top. So I have a 4n squared and a 3n squared. That would add to be 7n squared. I then look over here and I have negative 20n plus 12n. That would equal negative 8n's. And then it's still divided by n minus 5, n plus 4. Currently, if I tried to cancel anything out, I cannot, because this top is a binomial. That means I could only cancel it out if there was another 7n squared minus 8n that I could cancel it with, which there isn't. However, I know I'm not done the question. The reason I'm not done the question is because I go to my checklist and I ask myself, is there anything that can cancel or is there anything that can factor? I can factor that numerator. What could I do to that numerator? Take an n out. I could GCF the numerator. And sometimes after you factor as your final step, you create something that can cancel out. In this case, it won't, but we should always be doing that just in case. So I could take an n out, would leave me with 7n minus 8. And then the denominator, I would still have n minus 5, n plus 4. That's my answer because I cannot factor anymore, and I cannot cancel out any of those binomials with binomials. Adding and subtracting is much harder than multiplying and dividing. All right, let's try a subtraction question. First step is factor. Every single time. I can factor that. So if I look at it, the first one would become 1 over x minus 6, x plus 6. Then I have subtraction, 1 divided by, and I can factor that second thing as well. I'm going to factor out an x, but I'm actually going to strategically factor out a negative x. The reason I'm going to take out a negative x is then I know that it will reverse the order of those things. And the reason that would be handy is that would now look more like the first fraction. So if I take out a negative x, it would reverse the binomial, and I'd be left with x minus 6. (6x) divided by negative x would be negative 6. Negative x squared divided by x would be positive x. Just on the side, in case that's like, I see some people looking at that, like, what the heck's going on? So this is what I did. I took out a negative x. That left me with negative 6 plus x, because it changed the symbols. And then I just rewrite that. GCFing a negative does something else handy for me. It allows me to take advantage of that floating negative. Remember we said negatives on the bottom that are monomials we put to the top? There's another place we can put it. We can actually put it in front. So when I have this negative here, it can actually go to the top or the front right there. And it can change that subtraction question into a addition question. so that I now have this as my problem. 1 over x minus 6, x plus 6, plus 1 over x, x minus 6. If you didn't do that, you still have a subtraction question, that's fine. You can do it exactly like a subtraction question, and life would be good. I missed a bracket. All we've done is factored. That's it. That was the factor step. Step 2, non-permissible values. The NPVs on this thing. X cannot equal positive or negative 6. There's another NPV. What else would it be? 0. The reason it's 0 is because there's a monomial with a letter. Monomial with a letter right there. Awesome. Now, we want to combine those into one fraction because that's the first part of simplifying. To combine into one fraction, you need to have a common denominator. We'll start with the x minus 6. I have an x minus 6 in the first fraction. I look at the second fraction. There is an x minus 6. That's wonderful. That means we don't need to do anything with it. I look at the first fraction. I see that I have an x plus 6. That means the second fraction, I need an x plus 6. And what I do to the bottom, I do to the top. First fraction is now done. I look at the second fraction and I notice, hey, there's this monomial x. That means the first fraction needs a monomial x. And what I do to the bottom, I do to the top. I now have covered everything in the denominators to give me x divided by x, x minus 6, x plus 6, plus 1 times x plus 6 over x, x minus 6, x plus 6. I now have my common denominator. To combine that to become one fraction, I expand the top and then combine it. Looking at the first fraction, there is no expansion needed, right? This x is all by itself, so it's just going to continue to be by itself. The second fraction, I have this plus 1 that needs to be multiplied in. If you didn't write the 1, like I wouldn't have written the 1 normally, then all you're doing is putting the plus, the positive, into the brackets, which doesn't do anything. But it's a habit we get into because if it was a negative, the negative would matter. And we would have to put that negative into the brackets. So it's a habit I'm just going to create and continue that I put this plus into the brackets. It doesn't do anything. It leaves me with plus x plus 6. But it's a habit I want to create. On the bottom, I now just write my common denominator as the denominator. Once you have everything as one fraction, you are going to combine like terms. On the top, there is like terms. I have x plus x. That would become 2x plus 6 divided by x, x minus 6, x plus 6. I'm done when I can't factor and I can't simplify. Looking at that top, I could factor that. I could take a 2 out, making it 2x plus 3. The denominator cannot change, nor would we want it to change. And that is my simplified rational expression. How are we feeling about that? Okay. You remember it? A lot of you guys took 20-1. In fact, I think all of you did. Yeah. Not all with me, right? You did with me. Yeah, everyone took it with me. So you've done that question like 4 times now in your life. Okay. I'm going to rip through this one fast so you can see how quick it goes. So, and then the next one we'll start the day with. It'll be a subtraction question. If you're not here, which none of you guys are going to be here, I would definitely watch tomorrow's video on the subtraction because we haven't really done a subtraction question. We did that like little trick that turned the negative into a positive, but you haven't seen what happens when you can't do that trick. So please make sure that you watch that or do that example or take your friend's notes or something. This one though, if you wanted to rip through these questions, first step is factor. This factor is to be 5 x minus 5, x plus 5, because that was a difference of squares on the bottom. On the top is still 4. That trinomial you would never need to do, but it's x plus 5 times x plus 5. You would not need to factor that trinomial on a test. Second step is NPVs. X cannot equal positive or negative 5. Third step is simplify. To simplify, I want to write it as one fraction, then reduce. To write it as one fraction, I need a common denominator. This one has an x plus minus 5. This one didn't, so I give it an x minus 5. This one has an x plus 5. This one has an x plus 5. But if I look, this one has a second x plus 5. The first one does not, so I need to give it an x plus 5. What I do to the bottom, I do to the top. This now gives me a common denominator. I'm going to rewrite my work so that it's not so messy. I'll put the monomial in the front. So if I'm looking at that first fraction, I'm going to put the 5 out front and then x plus 5. The denominator, I'm going to write as x minus 5, but instead of writing x plus 5 twice, I'm going to go x plus 5 squared. Plus 4 times x minus 5. And in the denominator, I'm going to go x minus 5, x plus 5 squared. Awesome. I got a common denominator. The reason I want a common denominator is it allows me to combine them now. The way I combine them is by expanding the top. So the 5 is going to come into the brackets to become 5x plus 25. And the denominator does not change. So the denominator will remain x minus 5, x plus 5 squared. The plus 5 or the plus 4 will multiply in to become plus 4x minus 20. And I've kind of screwed up my bottom. I don't need to write it twice because I was expanding to write it as one fraction. So I realistically would write it like that. Now that I've combined it to be one fraction, I collect like terms. On the top, this would become 9x plus 5. The denominator stays x minus 5, x plus 5 squared. I know I've done the question because I cannot factor anything and I cannot cancel any binomials out with binomials because remember, there's brackets around that top.